Good afternoon, children. Welcome back to mathematics class, chapter 11, part 10, trigonometry. In today's class, you are going to learn sums from exercise 11.4 using the identities. In previous class also, you learned some identities of trigonometric ratios of identities of trigonometry and one sum from that exercise 11.4. In today's class, some more sums from exercise 11.4 we are going to learn. So let us move on to that. Evaluate. Second sum. Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Using the identity a plus b whole square is equal to a square plus 2ab plus b square and a minus b whole square is equal to a square minus 2ab plus b square. You have to expand it. Sin theta plus cos theta whole square is equal to sin square theta plus 2 sin theta cos theta plus cos square theta, that is a plus b whole square, and then a minus b whole square, that is sin theta minus cos theta whole square, that is sin square theta minus 2 sin theta cos theta plus cos square theta, and then add both expansions, then plus 2 sin theta cos theta minus 2 sin theta cos theta both will be cancelled. So leftover is sin square theta plus cos square theta plus sin square theta minus cos square theta. You know that sin square theta plus cos square theta value is 1, which is the identity, its value is 1. And again here also sin square theta plus cos square theta is equal to 1. So 1 plus 1, that is equal to 2. Now next sum. Evaluate secant square theta minus 1 into cosecant square theta minus 1. So we know that secant square theta minus tan square theta is equal to 1. This is second identity which is given. So from this identity, we will get it here that secant square theta minus 1 is equal to tan square theta. This is already given. This is also given one more identity in the class, in the video class. It's already given. So secant square theta minus 1 is equal to tan square theta. In place of tan square theta, you can write, in place of secant square theta minus 1, you can write tan square theta. Now, another identity is there, that is cosecant square theta minus cot square theta is equal to 1. And from this, you will get cosecant square cot square theta is equal to cosecant square theta minus 1. So cosecant square theta minus 1 is equal to cot square theta. Now, substitute this secant square theta minus 1 value in and secant square theta minus 1 value and secant square theta minus 1 value in the question, then we will get it here, the tan square theta into cot square theta. Again, cot square theta is the multiplicative inverse of tan, so change this into multiplicative inverse of tan. So tan square theta into 1 by tan square theta. So both tan square theta you cancel, left over is 1, the answer is 1. Now next up. Cosecant theta minus cot theta whole square is equal to, show that cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. Let's see this one. Cosecant theta is the multiplicative inverse of sine, so we'll write cosecant theta is equal to 1 by sine theta. Cot theta is equal to cos theta by sine theta. Now, so write cosecant theta as 1 by sine theta minus cot theta as 1 sine cos theta by sine theta whole square. That is equal to, take the LCM for both, denominators are same, so sine theta is LCM, numerator is, when the denominators and LCM are same numerator you will get it. So here 1 minus and here cos theta whole square. And now separate the squares, that is 1 minus cos theta whole square by sin theta whole square. A minus b whole square, you can write it as a minus b into a minus, that is a square, how will expand it, a into a. Similarly, a minus b whole square, you can expand it as a minus b into a minus b by sin theta whole square, we can write it as sin square theta. Now, we know that sin square theta plus cos square theta is equal to 1. From that identity, sin square theta is equal to what? 1 minus cos square theta. So, now Substitute 1 minus cos square theta in place of sin square theta in the equation. We will get it equation 1. Then we will get it 1 minus cos theta into 1 minus cos theta by in place of sin square theta you write it cos 1 minus cos square theta. Again we can change this denominator 1 minus cos square theta as using the identity a square minus b square. First you convert this in the form a square minus b square. Then change that into a plus b into a minus b. So I will convert this 1 minus cos square theta in the form a square minus b square. 1 can be written as 1 whole square and cos square theta we can write it as cos theta whole square. So a square minus b square. The expansion is 1 plus a plus b into a minus b, that is 1 plus cos theta into 1 minus cos theta. Then in the numerator we have 1 minus cos theta, denominator also we have 1 minus cos theta. Both are getting cancelled. And the leftover is 1 minus cos theta by 1 plus cos theta. Children, don't confuse here. Only the denominator part 1 minus cos square theta is written as in the form a square minus b square. Then later this is expanded using identity a square minus b square is equal to a plus b into a minus b. Then write that 1 plus cos theta into 1 minus cos theta here. Then cancel the numerator common parts 1 minus cos theta and 1 minus cos theta. Then leftover is 1 minus cos theta by 1 plus cos theta. This is very important for 2-mark question, children. It's very important for 2-mark question for the board exam. This sum. Now, another question. Root 1 plus sin A by 1 minus sin A. Show that root 1 plus sin A by 1 minus sin A is equal to secant A plus tan A. This root is for completely both numerator and denominator. So you see here, root 1 plus sin A by 1 minus sin A. What you must do is here, rationalize the denominator. You learned already how to rationalize the denominator in 9th standard. So when the denominator is a minus b, you should multiply the given question with a plus b, both numerator and denominator. That is called rationalizing. So here, that denominator is 1 minus sin a. So multiply both numerator and denominator with 1 plus sin a. In this way, the denominator will be rationalized. So 1 plus sin a into 1 plus sin a, which is what? 1 plus sin a whole square. A plus b into a plus b. That is a plus b whole square by denominator is in the form of a minus b into a plus b. So we can write it as a square, that is 1 square minus sin a whole square. 1 square minus sin a whole square is what? 1 square is 1 only and sin a whole square is sin square a. That means a square minus b square. Now 1 minus sin square a is equal to what? Cos square a. By using the identity sin square a plus cos square a is equal to 1. And from there, cos square a is equal to 1 minus sin square a. So, in place of 1 minus sin square a, you write a cos square a. Now, cos square a can be written as cos a whole square. So, 1 plus sin a whole square by cos a whole square. Because cos square a is nothing but cos a whole square. When you do cos a whole square, you will get it cos square a. Now, both are having the whole squares. Why I have to change it? Because if you convert both into whole squares, then this root and that whole square will be eliminated. That's why convert cos square a in the form of cos a whole square. Now, both are having whole squares. Take this into a common square. That is 1 plus sin a by cos a whole square. Root over 1 plus sin a by cos a whole square. Once again, I am telling this root is for completely both numerator and denominator here also. Everywhere in all these steps, the root is for both numerator and denominator. Then when you make this complete whole square, this root and this square if you cancel, then leftover is 1 plus sin a by cos a. Now separate it 1 by cos a plus sin a by cos a. You know that 1 by cos a is secant a and sin a by cos a is tan a. So this is proof that root over 1 plus sin a by 1 minus sin a is equal to secant a plus tan a. Hence it is proved. So my dear children, you must practice. This sum is also, children, very important for 2-mark question because this is given in so many papers for 2-mark question. So practice The sums which I explained in today's class, all the sums are very, very important for 2 mark question for the examination point of view. So, my dear children, first practice the identities. From each identity, again, 2 more identities are given. That also practice it, and then solve the sums. Then you will understand how that in place of cos square a, 1 minus sin square a is given is replaced, or how in place of secant square a minus 1 tan square a is replaced, how in place of cosecant square a minus 1 cot square a is replaced. This all you will be getting you will understand very easily if you know that all the 3 identities, and from the each identity again interchanging the identities, 2 more are also given. That also if you practice very well, you can understand all these replacements, how these are replaced, in what way these are replaced it, you can understand it, so that you can solve and you can practice the sum properly. So my dear children, practice this very well, and I hope you might have understood all these sums very well, children. So thank you very much. Thank you one and all.